Hello, Math 005. What we're looking at tonight, or today, depending on when you're watching this, is going to be 3.3 linear equations and intercepts. So what we're doing, you can see the objectives here, is we want to first recognize what a linear equation is. We want to understand intercepts, how to graph using the intercepts, and then we're also going to talk about graphing vertical and horizontal lines. First thing we have to talk about is the standard form of an equation. So standard form. This is anytime we have an equation in the form of ax plus by equals c. Now, whenever it's in standard form, a, b are going to be the coefficients of x and y, and then c is going to be your constant term. Now you'll notice that when an equation is in the standard form, your x and your y are being added together. The other thing you want to recognize is they're both in a numerator and they both have an exponent of 1. Those characteristics need to be true in order for it to be in standard form. If you cannot put an equation into standard form, then it is not a linear equation. So we have 4 examples here, or 1 example but 4 choices. Which of the following equations is nonlinear? And there is more than one answer. Remember, we said they have to be an x and a y being added together, and they cannot be in a denominator, and they cannot have an exponent other than 1. So what I want you to do is pause the video, look at choices A, B, C, and D, and see if you can decide which of those do you think would be linear and which one do you think are not going to be linear. Okay, so now that you've had a chance to look at those, let's go ahead and evaluate all these. The first one, you can see that the x and the y are on different sides, but even if we were to subtract an x squared here from both sides and move it to the other side, you would still have an exponent of 2, which means this one, which would not be linear. So this one is not linear. So we're circling the ones that are not linear. Let's see, let's go to letter B. Y equals 2x minus 1. Well, if we were to subtract a 2x from both sides, you'd get negative 2x plus y equals negative 1. You'll notice that this one is in the correct standard form. You have an x and a y being added together. Your coefficients, we have a negative 2, and the coefficient of y is just a positive 1, and we have a constant term. So this one is going to be linear. So I'm just going to put a star next to this one, just so we can say, yes, that one is. All right, let's look at this one. xy plus 2y equals 12. Well, here we have this product of x and a y. Because of that, that makes this not linear. So we do not want product. Do not want a product of x and y. That makes it not linear. And this last one here, 3 over x plus y equals 1. Now you'll notice that they are being added. However, this x is in the denominator, which makes this not linear because we do not want any variables in a denominator. So which ones are not linear? That would be A, C, and D are not linear. Okay, moving forward. Example 2. Use the graph below to identify the x and y intercept of the line. Well, we are going to call this down here. This is going to be our x-intercept. This is going to be our y. Now, it's kind of hard to see here, but you'll notice that this x-intercept, like we said, is right here. That is going to be the point. Our intercepts are always going to be points, and that's going to be the point 6, 0, over 6, up 0. This one up here is going to be our y-intercept, and that's going to be the coordinate 0, 4. The next thing says, what is the definition of the x and the y intercept? So these are going to be the points where the graph crosses the x and y axis, respectively. One thing you want to really make sure you keep in mind here is it's going to be the points. An intercept is always written as an ordered pair. Always answer intercepts as an ordered pair. What we're also going to do is, so it's easy to figure out our intercepts when we are looking at a graph, but we also need to find them algebraically. And so algebraically, how do you find these points? And we're going to be substituting 0 in for x and solving for y, and then doing the same idea, substituting 0 in for y, solve for x. So just the kind of thing we want to keep in mind, how do we do this? We are going to substitute 0 in for x and y separately. So we're going to do this separately. Okay, and we'll look at some examples on the next page. So now we want to use the intercepts to graph. So if it's telling you to use the intercepts to graph, you must do it this way. So you must do it this way if it tells you to use the intercepts. So when you submit any handwritten work, I'm going to be looking that you use the correct approach. So graph the line by finding its intercept. So to find the x-intercept, so we want to find the x-intercept. So where is it crossing the x-axis? So we're going to let y be equal to 0. So we're going to do 4x plus 2 times 0 equals 12. And then we're going to solve for x. 2 times 0 is 0, so we have 4x equals 12 to get x equals 3. So the x-intercept is going to be the point of x is 3 and our y was 0. So 3, 0, which would be this point right here. Then the y-intercept, so we want to let x be equal to 0 here. So we have 4 times 0 plus 2y equals 12. 4 times 0 is 0, so we get 2y equals 12 to give us y equals 6. So that's the coordinate 0, 6. So over 0, up 6, and that's going to be up here. Now what we have to do is connect those dots. And I can use, here I have this ruler, and so I want to line it up, connect my dots. Let's see, it's hard to get it too exact, but this will be as close as I think we're going to get here. And then we should be able to, there we go, perfect. Then we can draw our line. So that's how we graph using the intercepts. And then one thing we should always do is label our points. So we know this point up here is going to be 0, 6, and this point down here is going to be 3, 0. So now what I want you to do, I want you to pause the video and try example 4, following the same approach that we used in example 3. Substitute 0 in for x and y, and then solve for the other values. So go ahead and pause the video. Now you'll notice here that I used y equals 0, substituted my 0, and then I added my 3x to the other side to get 3x equals 3, so x equals 1 gives me the point 1, 0, which I plotted right here. X is equal to 0, so I substitute 0 in for x to get y equals 3 minus, that would be 0, so just y equals 3, the point 0, 3, plot that point, and draw my straight line. The next idea we're looking at is graphing horizontal and vertical lines. So what we have to keep in mind here is going to be the first thing is graph y equals 2. You will notice that even though this equation right here does not have an x, it's still in standard form because we could think of this as 0x plus y equals 2. So it's still in standard form, so it's still considered a linear equation. Now you'll notice that there is no x value, there is no x here. So that means that this equation does not cross x-axis. So no x, so it does not, this is not, cross x-axis, which means we're going to graph the line of y equals 2. That means it's crossed the y-axis at the value of 2. So if I bring my ruler down, and I can see that I have the graph of y equals 2. Now looking at the next one, x equals negative 3. So there's no y, which means it doesn't cross the y. But it's crossing the x at negative 3. So we're going to pull our ruler back up here. Again, you always want to make sure you use a ruler to draw all your lines. And then we have our line here. And that's the graph of x equals negative 3. This would be the equation of that line. All right, last but not least here, on to the last examples. Let's move this ruler out of the way. Write an equation for the graph. So what we're doing now is looking at the graph here. You can see, it's kind of hard to see, but here's the graph that we are looking at. So first thing when we do, we look at this, we'll notice that it's only crossing the y-axis. So that tells us your equation is going to be y equals something. And it's crossing at the value of y equals -3. Whereas in example 8, it's only crossing the x, so it's going to be x equals 4. And then the couple questions we have here at the bottom. Does a horizontal line have an x-intercept? So a horizontal line would be like this one. So a horizontal line is like example 7. Does that have an x-intercept? And we can say that no, it does not. And why or why not? We can say the line is parallel to the x-axis, so it doesn't ever cross over it. The next one, does a vertical line, so a vertical line is like example 8, so a vertical line would be like example 8. Does this have an x-intercept? And we'd say that yes, this one does. Yes, let's get rid of this. Yes, because all vertical lines will cross the x-axis. All right, that's all we have for 3.3. I hope this video helps you out and gets you started. Good luck, and ask me if you have any questions. Have a good one. Bye.